In this tutorial series, we will be focusing on NumPy. So let's dive into it. So first of all, what is NumPy? NumPy is a Python library used for working with arrays. It also has functions for working in domains of linear algebra, Fourier transform, and matrices. It is created in 2005 by Travis Oliphant. It is an open source project and you can use it freely. Now we have seen what is NumPy. Now let us discuss why we need to use NumPy. In Python we already have lists that serves the purpose of arrays, but they are very slow to process. NumPy aims to provide an array that is 50 times faster than the Python's list. The array object in NumPy is called NdArray. It provides lots of useful functions that makes working with NdArray very easy. So arrays are very frequently used in data science. In that case where speed and resources are very important. So let us now discuss why NumPy is faster than list. NumPy arrays are stored at one continuous place in memory, unlike list. So processors can access and manipulate them very efficiently. This behavior is called locality of reference in computer science. This is the main reason why NumPy is faster than list. It is also optimized to work with latest CPU architecture. You may now wonder which language is NumPy written in. Most of the libraries are partially written in Python, but for the most part that require fast computation are written in C or C++. As I said earlier, NumPy is an open source project. You can check out the source code for NumPy at this location URL here. To install NumPy, just head over to your command prompt and type pip install NumPy. So wait for a few seconds, it will take some time. So after the installation is complete, you can close this and open your favorite ideally. So I'm going to create a new Python file here. As you can see, it says requirement already satisfied. So let's import NumPy into our Python file. So let's import NumPy. So let's create our first NumPy array. So array equal to NumPy that array. So in this array method, just pass a list array of 1, 2, 3, 4, 5. So let's print our array variable. So let's save this and run now. As you can see, we have created our very first NumPy array. So if you check the type of this array variable, as you can see, it says class of NumPy NdArray. So we will discuss what is NdArray in the upcoming videos. For now, just know that it is a class of NdArray. So let's print the version of NumPy dot underscore version. As you can see, I'm using NumPy 1.23.5. So in most cases, you see import NumPy as NP, because instead of using NumPy, we will use NumPy. We will give NumPy a new name, so that is MP. So we don't use this full name. We will create a short name for it, that is NP. So let's save it and rerun now. The code will execute without any errors. As you can see, we just give a alternate name for this NumPy. So in the second part of the tutorial, we will be focusing on basics of NumPy. So to follow along this tutorial, you can either use Jupyter Notebook or on Google Colab. That is your choice, but here I am using the Google Colab. So just head over to Google and type Google Colab and click on collab.google. So after that, just click on new notebook. So wait for a few seconds, it's loading. So after the notebook is loaded, so let's give a name to our notebook. So let's give NumPy basics. So just click on connect here. So wait for a few seconds, it will allocate random virtual memory and disk. So it's initializing. Okay, now it is connected. So let's import our NumPy library. So to run in Google Colab, just click on the play icon here, or you can press shift plus enter. As you can see, this shell is now executed. So first of all, we will discuss what is NumPy. So NumPy is a Python library that stands for numerical Python. So it's primarily working with arrays. An array is like a list, but it can store more data and allow us to perform more mathematical operations efficiently. So to create an array in NumPy, we use the array function from the NumPy library. So we need to pass a list or tuple or any array like object to this array function, and this will convert it into a NumPy array. So let's see an example to understand this further. So array equal to np dot array of 1 comma 2 comma 4 comma 5. So let's print the array variable and also print the data type of array. As you can see, we have created our very first NumPy array. So it belongs to class ND array. Here we are created the NumPy array from passing a list. We can also create an array from a tuple also. So tuple array equal to np dot array of, just pass it tuple here. So 1 comma 2 comma 3 comma 4 comma 5. So just print the tuple array and also print the data type of this tuple array. As you can see, both these are same. It also belongs to class ND array. So we can create NumPy arrays in two ways. You can either create from a list or you can create from a tuple. So let us now discuss the dimensions available in NumPy. So first let us discuss the zero dimension array. So to explain zero dimension array in simple terms, just imagine a box where you put a single item into that box. So that's a zero dimension array. So it's like a single value in a container. So that's the zero dimension array, or we can say it is a scalar. So to create the zero dimension array, we pass a single value to the array function. So just create our zero dimension array now. So array of, so we're going to pass a single value. So let's pass 32 and see the type of this array here. As you can see, it also belongs to class ND array. So after that we will discuss one dimensional array. So to explain the one dimensional array, imagine a row of boxes. In each box you can put a single value. So that's the one dimensional array. So it's like having a putting zero dimensional array in side by side. So let us now see how to create the one dimensional array. So array of np dot array of, so we will pass the one dimensional values in an list or tuple format. So inside the list just pass the values. So let us now print the array. As you can see, it prints the values 1 up to 5. Now let us discuss the two-dimensional array. So imagine a table with rows and columns where each cell can hold the data. So that's precisely what a two-dimensional array is. It's a collection of rows and columns. So let us now see how to create a two-dimensional array in NumPy. So array equal to np dot, so it is nested inside the list or tuple. So inside this list we pass another list. So this is one row and this is another row. So let us now print and see what happens. So let's print array. As you can see, it's a collection of rows and columns. So this is the first row and this is the second row. So yeah, this is how we create an array in NumPy. So to conclude that we create a NumPy array using the array function from the NumPy library. So just pass on this array tuple or any array like object to the array function. It will convert that into a NumPy array. So now let's see how to verify the dimension of the array. As you can see, this is a two-dimensional array, but we can verify using the NDM attribute. So using this NDM attribute, it will display the dimension of that array. As you can see, it says 2. So this is a two-dimensional array. We can also use this in this one-dimensional array also. So just print the array.ndim. As you can see, it says 1. So this is a one-dimensional array. So next we will discuss the array accessing. So let us now see how to access the individual element from the array. So indexing in NumPy starts at 0, just like in most programming languages. So the first element has index 0 and the second element has index value 1 and the third element has index value 2 and the fourth element has index value 3 and so on. So to access the element in a NumPy, we use the square bracket. Inside the square bracket, just pass the element's index value in which you want to access. So if I want to access the first element, so I just pass the 0 inside the square bracket. So let's run now and see what happens. As you can see, it gives me the value 1. So let us see another example. So in this case, I'm accessing the second element. So that's why I have passed the index value 1. So if I run it now, as you can see, second element equal to 2. You can also perform an addition or subtraction or multiplication or division, all the arithmetic operations on the NumPy elements. As you can see, so I am performing addition operation on the element at the second index and the element at the third index. So the sum would be, so 3 plus 4 would give me the 7. So let's see and what it gives us. As you can see, it gives the sum value 7. So let us now move on to how to access an element from the two-dimensional array. So for this you need to pass two values. So one for the column and another one for the row. So the first one would be the column. So you need to specify which column. So in this case I am accessing the element of the first row and second column. So this is the row 1. So that's why I pass the first value as 0 and on the second column. So for the second column I just enter the value 1. So this is the first row and this is the second column. So this will give me the value 2. So let's run it now. As you can see, the element present at first row and second column is 2. So let's see another example. So let's now fetch the element present at second row and fifth column. So we are accessing the second row. This is here. So that's why I have passed 1 and the fifth column. So this has index value 0 and 1, 2, 3, 4. So this will give us the value 10. As you can see, it returns value 10. So let's now move on to how to access element from the three-dimensional array. So you need to pass three values. So first one is for the first dimension and second value is for the second dimension and the third value is for the element. So I am accessing the element at the first array. So inside that array I am accessing the second array. So inside that array I am accessing the third element. I know this is confusing. So first of all, before this, let's print our array to see how it looks. So let's close our parenthesis here. As you can see, the element at first array. So this is our first array. So inside the first array, I am accessing the second array. So this is the second array. So inside this array, I am accessing the third element. So the third element would be 6. So that's why for accessing this whole array, I am giving the index value 0. So inside this array, I need to access the second array. So that's why I have give the index value 1. So in this So in this array I need to access the last element, so thus I have given value 2. So that's why it returns the value 6 here. So this is how we access an element from the one dimension array, two dimension array and three dimension array. So next we will discuss is array slicing. So slicing means extracting specific portion of an array. So the syntax will look something like this. You mention the start index and also the end index. So it will extract the elements between those intervals. So let us see an example to understand this further. As you can see, we have this array. So I want the elements from the index 1 up to index 5. So this is the index value 1 element. So I need these 4 elements. So to perform the slicing operator, we use the colon here. As you can see, I want the element from index value 1 up to index value 5. But 5 is not included here. You need to understand it. So it is very important, 5 is not included. The end index is always n minus 1. That is, the element is not included. So if we run this, we will get the output as these 4 elements. As you can see, it starts from index value 1 and up to index value 5, but 5 is the 50 index value element is 6, but 6 is not included. So that's why we got these 4 elements here. So let us see another example to understand this further. So in this example, I haven't mentioned the end index. So that means it will start from the beginning and it will go to the end of the array. So it will start from this and it will go to the end. So this is the output we got. So let's see another example. So in this example, I haven't mentioned the start index. So it will begin from the start of the array. So it will begin from this and it will go up to this. So we will get these first 4 elements. So let us now discuss the negative slicing in array. So the last element is always having the index value minus 1 and this element is having minus 2 and this is minus 3, minus 4, minus 5 and so on. So you get the idea, right? The last element is minus 1. So I want the element from index 3 and up to index 1, that is minus 3. So this element has minus 3. So this is minus 2 and this is minus 1. So we will get these 3 elements if I run this. So let's run now. As you can see, I get these 2 values because as I mentioned, earlier the end index is not included. So that's why I get these 2 values here only. So you can also mention the step value as third argument here. So in this case, I want the elements between index value 1 and 5 with the interval of 2. So if I run this now, as you can see, I get the values 2 and 4 only. So this is the array we want to slice. So inside this array, I want the elements with the step value of 1. So that's why I got this value here, 2 and 4. So next is you can also slice an 2-dimensional array. So you need to pass 2 values, one for the rows and one for the column. So this will return index value 2 from the both arrays. As you can see, this is one array and this is another array. So it will return 3 and 8. So this is the second index from the both arrays. So let's run now and see what happens. As you can see, it gives us 3 and 8. So this is how we slice an array using the slicing operators. So let us now move on to the next topic. So for the next topic, we will be discussing the array iteration. So iteration means going to each element in the array one by one. So before that, let's import our NumPy library. So import NumPy as np. So click on this play button here. So next we define a very basic one-dimensional array. So array equal to np dot array of, inside this I am creating a NumPy array from a list. So I'm going to create a NumPy array with 5 elements. So to access the each element in the array, we can use the for loop. So for x in array, we're going to print the x. As you can see, it displays the individual elements one by one. So let us now see how to iterate on a two-dimensional array. So let's create our two-dimensional array. So array of 2 is equal to numpy dot array. Inside this I'm going to create a two-dimensional array. So for x in array 2, let's print our x here. So it will iterate on each row in the two-dimensional array. So in order to access the individual elements, we need to use another for loop. For y in x, let's print our y. As you can see, it displays the individual elements one by one. So let us now see how to do this on a three-dimensional array. So array 3 is equal to np dot array of, I'm going to create a three-dimensional array here. So let's copy the elements from this and paste it here and paste it twice, and let's include this. So for x in array 3, let's print our x. So it will iterate to, let us now see the output here. As you can see, it iterates through the two dimensions, that is, this is one element and this is another element. So so let us now use here another for loop to access the each row. So for y in x, let's print y. It will print the each row one by one. As you can see, it prints the each row one by one. So let us now use another for loop to access the individual elements. So for z in y, let's print our z. As you can see, it displays all the individual elements. So instead of using multiple for loops for higher dimensional arrays, NumPy provides a very powerful function called nditer function. Using that function, so you can access the elements in higher dimensional arrays using a single for loop. So let us now see how to do that. So let's clear this. So for x in, we're going to access the nditer function, nditer. So inside this nditer, just pass the array variable name. So array 3, let's print our variable x. As you can see, it gives the same result but with using only one for loop. So we can also provide a custom step size here. So I need all the rows, and for the column I'm going to give the step size 2. As you can see, it gives all the values with the step size of 2. So nditer function is a very powerful function with which we can use on a higher dimensional arrays. So let us now move on to next topic. So next we will see is an important topic, that is copy of an array and view of an array. So the major difference between the two is that, so when we make a copy of an array, we are creating an entirely new array with its own data. So that means if we change a element in the original array, it won't affect the copy of the array. On the contrary, if I created the view of an array, it does not own the data. It is just a view, as the name suggests. So if I change any element in the original array, it will also affect the view of the array. I know this is confusing. So let us see an example to understand this further. As you can see, I have this array here and I am copying the array using the copy method and store it in the x variable. I am changing the first element to 42. So let us now see the original array as well as copy of the array. So if I run this, as you can see, the original array is only changed. The copy of the array is not get affected. But if I change this copy to view method, So let's also change to view array. As you can see, I only changed the element in the original array, but it will also affect the view of the array. As you can see, the element at the first index in the view array is also affected. So this is the major difference between copy and view of the array. So next we will see shape of the array. So shape of the array will give us the how many elements are present in each dimension. So I am having a one dimensional array here. So if I print the shape of the array now, it will give me the result 5, because this is a one dimensional array, right? So inside the one dimensional array I have 5 elements. But if I create a two dimensional array with the elements, right? Wait a minute. So let's create a two dimensional array. Now if I print the shape of this two dimensional array, as you can see, 2 represents the it is a two dimensional array. So in each cell we are having 5 elements. So that's what this 2 comma 5 represents. So this is how we get the shape of an array using the shape attribute. So let us now discuss the next topic is reshaping. So for the definition of reshaping arrays, so I get here W3 school articles here. You can read it here. So reshaping means changing the shape of an array. So the shape of an array is the number of elements in each dimension. So by reshaping, we can add or remove dimensions or change the number of dimensions in each dimension. So let us see an example to understand this concept better. So I have this one dimensional array here with the elements of 12 elements. So I want to convert this into one 4-dimensional array within 3 columns. So how can I do that? So this is where reshaping comes into picture. So just to use the reshaping, we use the reshape method. So inside this, just pass how many rows and columns you want. So I want this to be 4 rows and 3 columns. So let us now print the new array. As you can see, we have converted this one dimensional array into one two-dimensional array with 4 rows and 3 columns. So now let us see how to reshape an one dimensional array into one three-dimensional array. So I have this array here with 12 elements. So let us now see how to change this into one three-dimensional array. So to change that one dimensional array into three-dimensional array, just pass 3 values. So the first value will be for the first dimension, and for the second value will be for the second dimension, and third value will be for the third dimension. So let us now print the new array and see what happens. As you can see, this one dimensional array has been converted into one three-dimensional array. So now let us see how to convert this two-dimensional array into one dimensional. So to do that, just print array of array dot reshape. Just pass -1 to this. It will convert an any two-dimensional or three-dimensional into one 1D, that is one dimensional. As you can see, it returns an one dimensional array. So in this video we will explore how to sort arrays using the NumPy library. So sorting is the process of arranging elements in a specified order, such as ascending or descending order. So NumPy provides a convenient function called sort function, allow us to sort arrays easily. So let's get started. So first we will see how to sort 1D array. So let's begin by sorting a one-dimensional array of numbers. First let us import the NumPy library. So import NumPy has np. So to run this, just click on this play button. So next let's create a array with some random elements. So array equal to np dot array. So inside this I'm going to pass some numbers. So I have an array with 5 elements. So let's change the numbers to randomly 7, 8. So we're going to sort this array in ascending order. So shorted array is equal to, just call the mp dot short function. So inside this short function, pass the array variable. So let's print our sorted array. As you can see, the array has been sorted. You can also sort the array in descending order by providing the negative slicing. So colon colon minus 1. So this will sort the array in descending order. As you can see, the array now has been sorted in descending order. So let us now move on to how to sort arrays of strings. So the sort function can be also used to sort array of strings. So let's create an array of fruits and then sort them alphabetically. So let's create an string array. So strings equal to, so inside this I'm going to just pass banana, then apple, then cherry. So let us see how to sort this array in alphabetical order. Sorted a string is equal to, just call the sort function like before, just pass the array variable name and just print the sorted array. As you can see, the array now has been sorted based on its first letter. We can also sort the boolean arrays. So let's change this. So let's change this to true, and this is false, and again this is true. So let's add a fourth element as false. So when sorting a boolean array, the false comes before true. So let's see how this executing. As you can see, the false comes before true. So now we have seen how to sort a one-dimensional array. So let us move on to how to sort two-dimensional array. So let's create a 2D array. So I'm creating a two-dimensional array here. So let's pass this to sort function and see what happens. So sorted array is equal to np dot sort. Inside this I'm going to pass the array two-dimensional array variable. So 2D array underscore array. So let's print our sorted array. Since the array is already in ascending order, there is no change in the output. So let's change the number to something else and see what happens. So let's change this to 1 again, and let's change the first element to 7. So let us now see. As you can see, the array is now sorted. So this is how we sort a one-dimensional array and two-dimensional array using the sort function. So let us now move on to next topic. So for the next topic, we will learn a fundamental concept in NumPy that allows us to extract specific elements from an array, creating a new array based on certain conditions. So it's called filtering. It's a very powerful tool that can be incredibly useful in data manipulation tasks. So first we will say what is array filtering, then we will filter arrays using a boolean index list, then we will create a filter array based on conditions, then we will simplify the process with direct array substitution. So first of all, what is array filtering? So imagine you have a large data set stored in a NumPy array. So you want to extract only specific elements that meet certain criteria. So this process of selecting elements from an array and creating a new array with them is known as array filtering. So let us say an example. So we will filter arrays using a boolean index list. So first we will create a very simple NumPy array and a boolean index list. So first of all, let's define our NumPy array here. So array is equal to np dot array. Inside this, I'm going to create this array with 5 elements. And for the boolean array, I'm going to create true, false, true, and then false. So the boolean index list contains true and false values corresponding to each element's index in the array. So if the value at an index is true, that element will be included in the filter array. So if it is false, the element will be excluded. So let's see let's create a filter here. So new array is equal to, so we're going to pass this boolean index list into the old array here. So let's print our new array. As you can see, we created a new array containing only elements at index 0 and index 2. So as those positions have true in the boolean index list. As you can see, that is true here. So the element at the index 0 is printed, and true is also located at index 2. So the index 2 element in the old array is printed. So only the positions have true in the boolean index list have printed here. So next we will filter arrays based on some conditions. So we have a array here. So mp dot array. Inside this I'm going to create 41, 43 and 40, 53 and comma 67. So we will filter array if the value is greater than 42. So filter array equal to, first this will be an empty list. So we will go through the each element in the array using the for loop. So for x in array, so if the x value is greater than 42, we will set the filter array to true, else we will append the false value. So based on the filter we have created here, we will create a new array. So new array is equal to array of, so inside the square bracket I'm going to pass the filter we have created. So let's print our new array here. As you can see, the elements with value greater than 42 is only printed. So instead of creating filter, we can also apply direct conditions on the array. So let's see an example. So let me copy this array here and paste it here. Print if the array is greater than 42. As you can see, it returns an boolean list. So the element at third index is 53. So it is greater than 42. And here also true. So the element at the last is also greater than 42. So now we have the boolean index, right? We can't capture this in a variable. So filter is equal to, so now we can create a new array using this filter. So array is, just pass the filter here. Now we can print our new array. As you can see, it displays the same result like before, but here we are applying the direct condition here instead of creating a boolean index list. So this is how you create a filter in NumPy. So for the next topic, we will see how to search array in Python using the NumPy library. So specifically, we will use the var function to find values that match a certain condition and retrieve their corresponding indexes. So this will help us easily locate elements that meet specific criteria within an array. So let's define an array here. So suppose we have an array here. So we have this array here. So our goal is to find the indexes where 4 is located. So to do this, we can use the var function. So when we run this code, it will return a tuple, as you can see here. The numbers inside this array is 3, 5, 6, which represent the index where the value 4 is present. As you can see, at the third index 4 is present, at the fifth index 4 is present, and the sixth index 4 is present. So you can also find the index where the values are even. So let's change this condition to is divisible by 2 and the remainder should be 0. So this condition will check if the number is divisible by 2 and the remainder is 0, then the number is even number, right? So let's check where that even number is located. As you can see, it is located in first index. So when the first index is 2, so it is a even number. Next is third index. At the third index we have 4 and then 5 and then 6. So we can also check for the R numbers also. Just change the remainder value to 1. So this will fetch the R numbers. As you can see, the R numbers are located at index 0 and at index 2 and at 4. So this is how we search an array using the where function. So before I finish this NumPy tutorial, I want to cover some useful NumPy function that will be really helpful for your data science career. So the first function we will discuss is linspace. So it will create a evenly spaced float numbers over a specified intervals. So first of all, let's import our NumPy package here. So import NumPy as np. So we're going to use the linspace. So the start value is 10 and the end value is 100 and the samples I want to generate is 10. As you can see, it generates an array with evenly spaced float numbers. So the next function is arange function. So it will return an evenly spaced integer values over a given interval. So np dot arange. So the first parameter will be the start value, then end value, then the step size. As you can see, returns an array with the specified arguments. So next we will see random samples. So if you want to create random sample from a uniform distribution between lower and higher limit values, then you can use this random sample. So np dot random dot uniform. So the start value is 10. So the start value is 5 and the end value is 10 and the size will be 4. So let's execute this. As you can see, it randomly creates an array. So the next function is array of zeros. So if we want to create an array with only zeros, you can do that now. So np dot zeros. Inside this, just pause the dimension of the array. So I want to create a two-dimensional array. So the data type will be an integer. So data type equal to int. So let's run this. So data type filling is so. As you can see, creation two-dimensional array. So you can also create the arrays with ones. So np dot ones. So inside this, I'm going to pause the dimension of the array. The data type of this. Now let us see the float. As you can see, it creates a float two-dimensional array. So next we will see how to create an array of k random values. So for this we're going to use the full function. So np dot full. So this as usual just pause the dimension of the array and the fill value will be 2. As you can see, it creates the two-dimensional array with the fill value. So next is we can also create the identity matrix using the identity function. So np dot identity. Say this, I'm going to create a four-dimensional array. As you can see, it creates the identity matrix. So if you want to get the minimum element from an array, you can use the min function. So let's create our array here. Np dot array a range of 5 to 1. Let's give 20 and the interval will be 2. So let's get the minimum of this array. So the minimum is 5. We can also get the maximum by using the max function. So the maximum is 19. So we can also get the mean of this array by using the mean function. Pass the array variable in here, and the data type of this array is integer. So the mean of this array is 12. So we can also get the median. So median, use the median function. As you can see, the median of this array is 12. So if you want to count the non-zero elements, you can also use the, so let's capture this in a variable. So you can use the count non-zero function to count the number of non-zero elements. So np dot count non-zero, pass the array variable name here. As you can see, the number of non-zero elements is 4. So yeah, these are the some useful NumPy functions that I want to cover. So I hope I have covered everything related to NumPy. So if you have any doubts, please leave in the comment section, and I will try to message all the comments as possible.